Alrighty, video number 2, here we go. We just finished this first problem on page 289. Let's go for the second problem on page 289. So I kind of smooshed into this space a little bit, so I will use a different colored pen to work on this one. In terms of y, describe the values of x for which the curve x cubed plus y cubed equals 4xy plus 1. Notice it's the same curve as this guy. Describe the values of x for which the curve will have a vertical tangent. Show your work and explain your thinking. So notice, again, this one they asked for the values, meaning we could find them. This one just says describe, which means, it's a subtle way of saying, we know that you're not actually going to be able to find the values, so just describe them for us. You'll see what that means in a second. So here we go. Vertical tangent lines, we know that happens when the derivative is undefined. We already found the derivative up here, so we're going to use that again. The derivative will be undefined when the denominator equals 0. So, solving that out, it says, in terms of y, describe the x values. So my x values are 3/4 of y squared. So it'll be where this relationship happens on the curve itself. So now I said to myself, wait a minute, shouldn't I be able to find the y values? So I tried it over here. It's a little bit faint, but there we go. I did the same thing we did up here where I just plugged it back in to the original function for x this time. But you end up getting a very similar looking equation. You end up needing the lost my train of thought. Sorry. You get that? Get that. Very similar. You end up finding y cubed is this guy, and then the cube root of that guy. However, that is really, really funky, and you would need a graphing utility to find the actual x values. So this is correct. That's a number. It's, I think, 1, 2, cube root, yeah, that's 2 numbers right there. However, that's y values. We want the x values. Plugging this in, we would not be able to solve for x. You would need a graphing utility of some kind to find those x values, which is why they only ask you to describe them, not actually find them. Therefore, this is not what they wanted you to do. They want you to say this. Right here is my description. So, on the curve, right here, on that curve, x and y values that relate like this will have vertical tan lines. There we go. So it has to be where the xy values behave like this, but they have to be on that. And to figure out exactly where that happens, we would need a graphing utility, which is why they just said to describe. There we go. Okay. Then, moving on. The next 2 boxes, this is going to be super easy for us. Again, let me cover this up so we don't see everything. Here we are. This notation is a fancy way of telling you to take the second derivative. Usually we would say y double prime or f double prime of x, but this is the Leibniz notation of it. This is the second derivative. So what you're going to do is first implicitly differentiate this guy the first time. There we go. And then solve it for dy dx. I did, and then I simplified it, so this is my first derivative, all simplified. Then they want you to differentiate it again, just like we would take the second derivative in the past. So my second derivative, it's super easy to find now that it's already explicitly solved for the first derivative. I just differentiate. The derivative of the derivative is the second derivative. The derivative of this guy, I need the quotient rule on this particular one. I do my quotient rule, I'm going to get dy dx again. So notice quotient rule, low, y plus 1, d high, 0, minus high, 1, d low. So now the derivative of y plus 1 is just the derivative of y all over the low squared, y plus 1 squared. But here's the thing, I don't want my derivative inside my second derivative, so what I did is I simplified this. Notice this is just equal to 0 since I multiplied by 0. So I have negative 1 times the derivative, but the derivative we already found. It's 1 over y plus 1. So in that spot, I put my first derivative. So this guy right here is my first derivative within the second derivative. And I simplified that. I saw that it was y plus 1 for both of those, so I could simplify down here. Negative 1 over y plus 1 cubed. That is my second derivative. There we go. So, again, if you have any questions, talk to each other, ask each other about these steps. What I want you to do next is try the next box. It's asking you to do the same sort of thing. Try that first. So pause this video, try that, and then when y'all think you are ready, look at the video again to finish off this. So pause it at this time. And now let's look at the answers. So here we go. I'm differentiating, not that bad. I solve it for dy dx, and I simplified it a good bit. That's my first derivative. And then we find the second derivative. My second derivative is going to involve the quotient rule again. Again, I have my first derivative within my second derivative, and I don't like that, so I make this substitution. My second derivative right here, and I should have done this in 2 steps. So this guy, I end up getting negative y plus x dy dx all over y squared. That's how that simplifies a little bit. When I plug in dy dx, that is negative x over y, which we see happening right here. I gave myself an over 1 fraction, just so I knew how they combined. This guy, it was negative y, but I needed to have a common denominator with this piece over here. So that is why it now looks like negative y squared over y. We know that would simplify to negative y, that guy. So I was just looking for a common denominator there. All of that is over y squared. And then my second to last step, I can combine what I see on top. I'm subtracting negative x times negative x, so I'm subtracting x squared over y. That's all in the numerator. All over y squared. Then I simplify it out. There's my final answer. Negative y minus x all over y cubed. Combining those denominators there. There we go. So again, pause this video. If you need some help on this one, talk to each other to figure that one out. And again, this video is getting long, so I am going to stop it and give you some more examples on the next video.